Assalamualaikum. So today we are going to present our case study, which the title is Crystalline Solid. This is our team members, which consists of 5 people in this group. Which the first one is myself, Fazarin, and the second one is Amin. The third one is Irfan. Next is Imad, and the last one is Hazrul. So let's move to our first slide, which is the objective. We have 4 objectives in this case study, which is the first one is to define what crystalline solid is. And the second one is to describe the characteristic of crystalline solid. And the third one is to identify the type of crystalline solid. And the last one is to understand the importance of crystalline solid in inorganic chemistry by relating their structure to real examples and application.
Now, this part shows about the introduction to our topic. In general, solids can be classified into 2 main types, which are crystalline solids and amorphous solids. The main difference between these 2 types lies in the arrangement of their particles. Crystalline solids have a regular and repeating atomic structure, where the atoms or ions are arranged in an orderly pattern throughout the solid. Because of this regular arrangement, crystalline solids usually have well-defined shapes, sharp melting points, and consistent physical properties. In the other hand, amorphous solids do not have a regular arrangement, and their particles are arranged randomly. However, in this presentation, we will focus more on crystalline solids. Many inorganic compounds, such as metals, ceramics, and salts, exist naturally as crystalline solids. Therefore, understanding the structure of crystalline solids is very important as it helps us explain their properties, behavior, and applications in science and engineering. This basic knowledge will help us better understand the topics that will be discussed in the following slide. Next, we move to the next part. What is crystalline solid? A crystalline solid is a type of solid where the particles, such as atoms, ions, or molecules, are arranged in a fixed and orderly pattern. This means the particles are not randomly arranged, but follow a specific structure. One important characteristic of crystalline solids is that this arrangement repeats continuously in 3 dimensions. In other words, the same pattern extends throughout the entire solid, whether it is viewed from the top, side, or inside the material. This regular and repeating arrangement of particles is known as a crystal lattice. The crystal lattice is responsible for many important properties of crystalline solids, such as their definite shape, strength, and sharp melting point. Because of this well-organized structure, crystalline solids are commonly found in many inorganic materials, including metals, salts, and ceramics, which are widely used in engineering and industrial applications. Understanding the concept of a crystal lattice is important because it helps us explain how the structure of material influences its physical properties.
Next, for characteristic of crystalline solid, there are 4 points, which number 1 is definite geometrical shape. Number 2, we have high degree of order. Number 3, we have sharp melting point, and the last one is anisotropic property. Crystal lattice and unit cell. What is a crystal lattice? A crystal lattice is the 3D arrangement of particles in a crystal. What is unit cell? Unit cell is the smallest repeating unit. So, repetition of unit cell forms the entire crystal. Next, types of crystalline solid. There are 4 types, which number 1 is ionic crystals. Number 2, we have metallic crystals. Number 3, we have covalent crystals. And the final one is molecular crystals.
Next is finding and discussion. First of all is crystalline solid show regular and repeating structure. Next, different type of bonding lead to different properties. Besides, strong bonding result in high melting point, such as in ionic and covalent crystal. Moreover, weak forces result in low melting point, as seen in molecular structure. Last but not least is structure directly affects physical properties such as hardness and conductivity. These arranged particles form a crystal lattice that give each solid a unique shape and behavior. The way particles are held together determines how the solid respond to heat, pressure, and electrical flow. So we move to the importance in inorganic compound. The first is helps explain the behavior of inorganic compound. Secondly, is important in solid state chemistry. Lastly, this knowledge is widely used in the development of ceramics, metal, semiconductor, and catalysts.
So, in conclusion, crystalline solids have a well-organized and repeating structure that give them special physical and chemical properties. Learning about this solid is important in inorganic chemistry because it helps us better understand how material behave and how they can be used in a real-world application.